everyone, have you ever stopped to wonder how you can type your credit card number into a website and have it magically arrive securely without some hacker on the coffee shop Wi-Fi snatching it out of the air? Well, that little bit of magic has a name, asymmetric cryptography. And today, we are going to crack that code together.
So, here's the plan. We're going to start with a huge problem in the world of secrets, something called the secret key dilemma. Then, we'll get into the brilliant two-key solution that changed everything. We'll break down exactly how it works, look at the gold standard algorithm, you might have heard of it, RSA, and finally, we'll see where this incredible tech is hiding in plain sight, protecting you every single day. All right, so let's dive right in with the fundamental problem, a real puzzle that kept people up at night for centuries. Just, picture this. You and a friend are trying to pass notes in class, but the room is full of nosy people. How do you possibly write something that only your friend can read, even if somebody else gets their hands on that note? I mean, that's it. That is the core challenge of secure communication. Now, the most obvious answer is to come up with a secret code, right? In our world, we call that a key. You use the key to scramble or encrypt your message, and your friend uses that exact same key to unscramble or decrypt it. This is called symmetric encryption. One key does both the locking and the unlocking. Seems simple enough. Yeah, well, here's the catch. There's a massive, glaring flaw in this plan. What happens if one of those nosy classmates, what we'd call a man in the middle, grabs the key while you're trying to pass it to your friend? Suddenly, your entire secret code is blown. They can now read every single message you send from then on. And that leads us to this total paradox. To talk in secret, you need a secret key. But to get that key to your friend safely, you need a way to talk in secret. It's the ultimate chicken and egg problem, and for a long, long time, it seemed completely unsolvable. But then, in the 1970s, a totally revolutionary idea came along that just flipped the whole problem on its head. It was a complete game changer. So, instead of that one shared secret key that you have to protect, what if you used a pair of keys? Two keys that are mathematically tied together. One key would only be used for locking messages, and a completely different key would be used for unlocking them. This is the core idea behind asymmetric cryptography. We call this public key cryptography, and it works exactly like it sounds. You have a key pair. One is your public key, which you can literally post on a billboard, give to anyone, it doesn't matter. The other is your private key, and that one you guard with your life. You never, ever share it. Okay, so two keys, one public, one private. How does that actually fix our secret note passing problem? This is honestly the perfect analogy. Think of your public key as the mail slot on a locked mailbox. Anybody in the world can walk by and drop a letter into that slot for you. But, and this is the important part, only you, the person with a unique private key, can actually open the box to read what's inside. It's brilliant. So let's just walk through it. Say I want to send you a secret message. First, I just ask for your public key. You can send it to me over an insecure email, shout it across a room, whatever. It doesn't matter who sees it. Second, I take your public key and use it to lock my message. Now, here's the magic. Once it's locked with your public key, it can only be unlocked by your private key. Third, I send that scrambled nonsense message over the internet. And finally, you get it and you use your private key, the one that only you have, to unlock it and read it. And just like that, the key exchange problem is solved. Now, this whole concept isn't just a cool idea. It's powered by some seriously clever math. And the most famous, most widely used version of this is an algorithm known as RSA. RSA gets its name from its creators, Rivest, Shamir, and Adelman, three geniuses who figured this out back in 1977. Its incredible security comes from a simple fact. It is really, really hard for computers to find the two original prime numbers that were multiplied together to make a gigantic number. And for decades, that principle has been the very backbone of our digital security. And here's where it gets even cooler. RSA can do two amazing things. First, confidentiality, which is what we've been talking about. Lock a message with a public key and only the private key holder can read it. Simple. But you can also run the whole thing in reverse. If you lock something with your private key, you create what's called a digital signature. Now, anyone with your public key can unlock it, so it's not a secret, but it's undeniable proof that the message could only have come from you. That's authentication. That's how we prove who we are online.
So why does any of this techie stuff matter to you? Well, because you are using it dozens, maybe even hundreds of times a day, and you probably don't even realize it.
Seriously, every single time you see that little padlock icon in your web browser, every time you log into a secure network, every time you send an encrypted message, this whole two-key system is the engine running under the hood, keeping you safe.
Public key cryptography is the foundation of secure web browsing, HTTPS. It's what powers VPNs that protect your internet traffic. It's what secures certain emails. And it is absolutely essential for the end-to-end encryption in chat apps like Signal or WhatsApp. It is literally everywhere.
Okay, but here's the final, really clever twist. It turns out that asymmetric encryption, the two-key system, is incredibly secure, but it's also kind of slow because the math is so hard. The old symmetric way is way faster, but it has that key-sharing problem. So what do? We use both. Modern systems use the slow, super secure asymmetric method for just one quick moment at the start of a conversation to safely exchange a brand new, one-time use symmetric key. Then, for the rest of the chat, they switch to that lightning-fast symmetric key. It is truly the best of both worlds, rock-solid security and blazing speed.
So when you boil it all down, our entire global system of digital trust, from shopping online to proving your identity, it all rests on one simple idea. Your private key has to stay private. It's the master key to your digital life. All the brilliant math in the world can't protect you if that key gets out. Which leaves us with one final thought to chew on. In a world built on these public and private keys, what are you doing to protect yours?